Afternoon. Okay, so today we are going to be looking at permutations and combinations. We're actually getting into probability and statistics at this point, which we can actually have some fun with. We'll use some dice maybe at some point, maybe play with some playing cards. So we're looking at permutations and combinations, which is a form of probability. Okay, so when we look at this, some stuff that you need to know is what we call the multiplication counting principle. And basically it says if there are m ways to make a first selection and n ways to make a second selection, then there are m times n ways to make the two selections. So for example, if I have 6 shirts and I have 2 pairs of pants, and I want to know how many different choices do I have, combinations do I have? Well, I have 6 to choose from, 6 ways to choose shirts, and I have 2 ways to choose pants, so I would have 12 ways total, which would be 6 times 2. Permutations now are an arrangement of objects in a specific order. So anytime they're talking about you choosing between a certain number of things and they have to be in some sort of an order, that's what we call a permutation. And we're going to use this formula. N is the number of objects you're choosing from, and R is the number of times, R is actually going to be how many you're choosing at a time. Okay? Then it's going to be in order to find out how many I have, I'm going to use this formula right here. Which is actually the next word. This here is what we call a factorial, which we'll get to in a minute. So it's going to be n factorial here over n minus r factorial. Now factorial now is the product of integers from n down to 1. So if I say let's use a smaller number. If I say 3 factorial, that is the product of the integers from this number here all the way down to 1. Okay? So this would be 6 times 1, which would be 6. So 3 factorial equals 6. Alright? Now a combination is a selection of objects without regard to order. Okay? So with these specifically, there is no order to it. You're just picking from a group and you're picking a bunch of stuff out. Okay? So in this case, it would be you're choosing n items, and you're choosing them r at a time, and it would be n factorial over r factorial times n minus r factorial. Really, with this kind of stuff, it's really just doing some examples and learning how to do it, okay? So you decide to watch 3 movies at home in a row. You have a comedy, a drama, and an action movie to choose from. How many different orders for watching the movies are possible? Now with this problem, I'm going to show you another way of doing this besides using formulas and all that kind of stuff. Alright, you can use what we call as a tree diagram. Okay, so I'm going to write my 3 choices. I have a comedy, I have a drama, and I have an action. Okay, and now from here we're going to branch off all the different options that we have. Okay, so this is our first movie, which means for my second movie I can choose a drama, or I can choose an action, and that means if I choose a drama, I would choose an action next. Or if I chose an action, I would choose a drama next. Okay? And we're going to do the same thing here. So the first option, let's say we choose a comedy. Or I could choose an action. If I choose a comedy, I'm going to choose an action for the third movie. If I choose an action for the second movie, that means I have to choose a comedy. for the third movie. And then we're going to do the last one. So I choose an action first. I'm going to choose a comedy second, which means I would have to choose a drama third. Okay? Or instead, I could choose a drama second, which means then I would have to choose a comedy third. Okay? So now how many different options do we have? Well, here is one. Okay? Here is number 2. Here would be number 3. And number 4 would be the red one. Number 5. And then the last one then would be number 6, which would be here. Okay? So doing it this way, we can see that we have 6 different possibilities. Okay? Now, let's look at, let's go ahead and let's look at how many, let's look at another example now. Okay? So for example number 2, it says a band has 7 new songs and wants to put 5 of them on a demo CD. How many arrangements of 5 songs are possible? Okay, so for example, we could just say the first order would be, and I'm going to abbreviate the songs as S1 through S7. Okay, so I could say the first one would be S1, S2, S3, S4, S5. Alright? And I bet you could come up with another one. Okay? So we could say number 2 would be S2, S3, S4, S5, and S6. Okay? So that's 2 orders right there. They want to know how many do we have possible. Now this is talking about an order. Alright? They have to be in a specific order. So how many different orders can I choose from? So this is going to be a permutation, because remember, permutations are talking about a specific order. Alright? So now, and remember, you're looking for its N, P, R. P is representing the permutation, N is representing how many items you have, and R is how many you're choosing. Okay? So N in this case, we have 7 songs, and R is going to be how many we're choosing, which is 5. So now I'm going to plug it into the formula, which is 7p5 equals n factorial, so that's 7 factorial, over, it's going to be n minus r factorial underneath. Okay? I'll actually write that here in just a second. So this is going to be n, which is 7, minus r, which is 5 factorial. Okay? Now I'm going to show you how we can do this using a calculator. And I'm also going to, well, doing a calculator is fairly easy, okay? But I'm going to show you how to do this not using a calculator. So 7 factorial, we know, is 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? And now, the bottom, 7 minus 5, is 2 factorial, so that's 2 times 1. Well, because this is all multiplication on top and all multiplication on the bottom, I can cancel this here. Which means this is going to equal 7 times 6 times 5 times 4 times 3. Which is, let me actually grab a calculator myself, because you can do this a long way, but no point in it. And this is 2,520 arrangements. Okay? you do this. It's not all that hard, and tomorrow while you guys are in here, we'll get out the calculators and I'll show you how to actually do this on a calculator as well. But this is an example of one where it's asking for a specific order, okay? Now let's go to example number 3. Example number 3 says 20 people report for jury duty. How many different 12-person juries can be chosen? So the first question you got to ask yourself is, are they looking for a specific order? Or are they just looking for you to choose a group out of a bigger group? Okay? And in this case, it doesn't say anything about an order of any sort. It just says how many different 12-person groups can you choose. So this is going to be a combination. All right? And remember, the combination is NCR. N is still representing the same thing. It's how many do you have total. R is how many are you choosing. Okay? So that means that N is going to be 20 because I have 20 jurors total, and R is going to be 12 because I'm choosing 12 jurors at a time. So now I'm going to go ahead and I'm going to plug it into the formula, which is 20, and remember these are small, these are subscripts, okay? C12 equals, it's going to be N factorial, which is 20 factorial, over this is R factorial, which is 12 factorial, times N minus R factorial. Okay? So let's go ahead and I'm going to write this out now. You have 20, 19, 18, 17, 16, 15, 14, and actually I'm going to erase some of these here. You guys get the idea. So this would be dot, 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 which means I'm going to skip, and we're going to go 2 times 1. Okay, so I have all these numbers in between. This is over 12 factorial Let me actually rewrite this a different way. Okay, 12 factorial, and this is times 20 minus 12 is going to be what, 8 factorial? Okay, the top, you have 20, 19, 18, 17, 16, 15, 14, 13, 12, 1. Okay? So I have 12, 11, 10, 9, 8, 7, 6. The dots here just means I'm not writing it, but you can see the pattern. Okay? Now, 12 factorial is 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5, all the way down to 1. So I can cancel 12 factorial and all of this here. Okay? So now I'm going to rewrite what I have left, which is 20, 19, 18, 17, 16, 15, 14, 13, over 8 factorial, which is 8, 7, 6, 5, 4, 3, 2, 1. Okay? So this is what I have left. Now at this point, this is obviously a lot easier with a calculator. Okay? But if I can't use a calculator to help myself out, I just canceled some of it right here when I canceled 12 factorial with this here. Okay? So now I'm going to look at what I have left, and I'm going to see what else I can cancel out. For example, 7 and 14 cancel out, and I'm left with a 2 at the 14 and a 1 at 7, because 14 divided by 7 is 2. Since this is all multiplication here on top and bottom, I can just start canceling things. 13 is not going to cancel with anything because 13 is prime. Okay? We're going to do 8 and 16. 16 becomes 2. The 8 becomes a 1. We're going to do 6 and 18. The 18 becomes a 3, and the 6 becomes a 1. We're going to do 5 and 15. This becomes a 3. And 5 becomes a 1. I have 4 and 20. 20 becomes 5, because 20 divided by 4 is 5. The 4 becomes a 1. 3 does not go into 19, 17, or 13. But I can still cancel with what I have up here. Okay? 19 is going to have nothing that goes into it. 17 will have nothing that goes into it. The 1 doesn't matter because anything with a 1 is just 1. Okay? So now let's see what else we're able to cancel at this point. So I'm going to go ahead and rewrite what I have left. So I have 5 times 19 times 3 times 17 times 2 times 3 times 2 times 13 all over all these ones. That's 1 times 1 times 1 times 1 times 1, which is just 1. So I have 3 times 2. So now let's cancel one more time. So I can cancel this 3 and this 3. They both become 1s. I can cancel this 2 and this 2, and they both become 1. So this is going to give me now 5 times 19 times 17 times 3 times 2 times 13, which equals, so now this is a lot less work doing multiplication on your calculator or anywhere else, or even if I had to do multiplication by hand. It's a lot easier to do this than to do all that multiplication, 20 factorial, and then divide it by all that other multiplication. Okay? So 5 times 19 times 17 times 3 times 2 times 13 is 125,970. Okay? So we will do, I'll probably do at least one more example of this tomorrow while you guys are in class, but please take good notes. Write an explanation, steps, something to help you. Okay? Rewatch the video if you need to. Listen to what I'm telling you. It will help a lot. Alright? Okay guys, I will see you tomorrow. Come to class ready to work and have your notes done. Have a great night.